Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 5B. My name is Alesha Mullah, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD 2026 in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, and the virtual event is being held from 9th to 11th July 2026 via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes for presentations and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for today's session. Dr. Nilesh Popat Savale is the professor and head of the Department of Computer Science and Engineering, Artificial Intelligence at Vishwakarma Institute of Technology in Pune. A senior member of IEEE, he brings over 16 years of academic and research experience. He has published more than 75 research papers, holds 16 patents and 18 academic copyrights, and specializes in machine learning, data mining, and networking. I now request you to please say a few words.
Yes. So thank you, GR Foundation and Amit sir for this invitation and giving me a chance to serve as a session chair for this technical event. Hopefully, we will have a great learning today. Uh, be focused on your objectives only instead of giving more about introduction. See that you focus on your objective and finding. So looking forward for this technical session. Thank you. Thank you, one and all.
Thank you, sir. Now we would like to start with the presentations. Our first presentation for today is by Karthik Chitre, who will be presenting a comparative study of sketch-to-face reconstruction approaches based on identity preservation, photorealism, and deployment feasibility. Karthik, you may now begin your presentation.
So, hi, I am Karthik Chitre, and let me just share my screen. Yeah, is my screen visible?
Yes, it is.
Okay, so to continue with, I'd like to introduce my colleagues. That is Basil Parker, Kaap Pavne, me, myself, Karthik Chitre, and Siddesh Raj. Our professor guide was Professor Smurti Vyavhare. And to begin with, let's introduce like introduction, motivation, and all these are the contents of our PPT. Introduction. So now, basically, to go further, to introduce with our project, I'd like to introduce it like facial sketches are widely used in forensics investigation processes for criminal branches and forensic departments. So these sketches basically depend on human memory. Uh, Now the traditional methods like making a sketch and then finding a culprit are very difficult and they are not reliable enough. So the existing system fails to maintain the photorealism and the identity of the victim or the accused. Now, advanced deep learning features, techniques and computer vision enable us to automatically develop the probabilistic photorealistic images. So now this project helps proposes us a hybrid AI-based system to generate realistic and identity-preserving faces. Now, so the challenge it was we were facing was in many investigation, no photographic evidence is available uh, during the crime or the crime being performed. So human-based identification is time-consuming and unreliable. So need for automated, accurate, and scalable solutions. Existing models fall short, like generate realistic images but lose identity, or preserve structure but lack realism. No system effectively balances both. So our goal was to build a system that improves forensic identification accuracy using AI, accurately using AI. So now the problem statement goes like current sketch to face conversion techniques either focus on generating visual realistic images or preserving identity features, but fail to achieve both simultaneously. This system also performs these systems also perform poorly on low quality and inconsistent cases. So now for that we needed a hybrid deep learning model. So after literature review goes like these are the previous models and the key findings which are listed over here with the authors. So after that, comparison of models. So like traditional methods use manual featuring machine which has low accuracy and the limitation is subjective and unreliable. CNN based models are convolution feature extraction, improved detection, but need large labeled data sets which are very difficult to get like to proctor them. And then pix to pix GAN, style GAN 3, PSP encoder, and hybrid GAN approaches. So our proposed system uses pix to pix, style GAN, and PSP encoder, all of these in one model using transfer learning. So which basically gives us high realism plus strong identity and balanced effective solution. So research gaps were like existing models fails to balance realism and identity preservation. GAN-based approaches generate realistic image but do not preserve facial identity. And encoder-based models preserve structure but lack visual realism. Most systems rely on single model architecture, limiting performance. Poor handling of real-world forensic sketches, which are basically low quality and inconsistent, and lack of scalable, user-friendly deployment systems. So our objective was develop a hybrid learning system for sketch to face conversion, convert facial sketches into realistic high quality images, preserve key identity features, facial structure and proportions, handle low quality, noisy and incomplete sketches effectively, improves accuracy and reliability of generated facial images. And main was maintain balance between realism and identity preservation. So the three model pipeline which we have used is Pix to Pix GAN, which is a very basic sketch to sketch image generation. Then the style GAN 3 and the PSP encoder. So here we'll go further with the models. So scope of the project was sketch to photos conversion, identity aware generation, flexible input handling so that the user experience is good, hybrid model pipeline, proposing a pre-processing and feature extraction and web-based application. So yeah, we have developed a web-based application. So to go further with the methodology, first the sketch pre-processing will be done. That is the noise in the sketch that the model finds will be removed. Edge enhancement, that is for the feature extraction, is very necessary, and the resizing of the image. Then there comes the model pix to pix. It is basically used for structure generation. It is a UNet generator model, which is a generator and a discriminator model. And then the third point is realism enhancement, which is done by StyleGAN 3. That is, it handles texture and lighting of the sketch to generate the realistic image. And then the PSP encoder comes in, which basically is used for identity preservation. So it deals with the facial consistency, the facial features of the sketch. And the last step is to combine all these models and give a photorealistic image, that is combine realism plus identity. So now the algorithm works like input and pre-processing. That is, we need to upload the sketch, validate the format, resize, remove the noise in it, normalize, and enhance the edges. Next comes with structure generation. That is, pix to pix takes the lead, generated the initial phase from the pre-processed sketch. Cyan 3 enhances the textures, lighting, and photorealistic details. And then the PSP encoder preserves identity, realism plus identity, and fused into final image display. So these are the steps: submit, analyze, and identify for our investigation protocol. So this is the basically our UI. This is the very first stage of our UI where the it says identify suspects. Then if we just zoom into it and notice that here it is the page for evidence upload. So when we click on choose file, we can browse through our computer and then we can upload an image over here. Once the image is uploaded, the investigation starts, the model starts working in the backend. And after that, the results and outputs are shown to you as this. So for example, we uploaded an evidence like sketch, evidence submitted and sketch for this photo. So the output is this. So the subject identified would be this person. And for the further process, you can save the case file in a PDF or a document. So these are the points which we focused mainly on. That is, it is strong. Identity preservation across the sketch is done. So if you can see like uh, the sketch and the photorealistic image generated by our model is mostly 90% of the times it is same. And then improve the texture, lighting, and the detail. That detail, if you can focus, like, sorry, the Mostage is exactly the same. The specs are exactly the same, and the background. The background may vary sometimes because it is not so fixed or determinable. But the noise in the sketch is reduced. Exactly, you can see the photo or the face or image of the person. You can imagine it. So the main point is our model, which we trained, is robust. Like it can perform on low quality images also. And to conclude the project, we like designed a hybrid deep learning pipeline that converts in a facial sketch into a photorealistic image, which is mainly focused on balanced photorealism with identity preservation. So as I said above, we integrated three main models, that is Pix2Pix, StyleGAN 3, and PSP encoder in one unified system. Then we archived high quality outputs with image, improved texture, lighting, and reduced artifacts, handled low quality, noisy, and statistically varied sketch through pre-processing, delivered a user-friendly web application using React plus Flask for investigator use. And these were the references which we used. Yeah,
Okay. Just 1 minute.
yeah,
Now, what you have done, you have clubbed these three together. After
yeah, sir.
clubbing, have you
Mhm.
compared the accuracy aspect of all three?
Yes, sir. Like to comparing the accuracy aspect, like we basically trained and took the outputs one by one. Like we first trained Pix2Pix from the very basic, then the output was not even identifiable. So we then included the StyleGAN 3 model. So for using the StyleGAN 3 model, we basically need a PSP encoder. The PSP encoder is basically a Pix to style to Pix to Pix to style to Pix encoder, which handles the latent code. That is, it fills the latent space, which is required for the StyleGAN 3 model to work. So after using all these three in transfer case learning, we have received this. Like after fine tuning the model on the
Have you
local
gone through
data
the
set.
matrix? Have you gone through the matrix like precision, recall,
No, sir.
of both
Like
comparison of
not
that?
in depth, not in depth.
Okay, fine. Thank you.
Thank you, sir. Shall I close this PPT?
Yes.
Thank you.
All right. Now moving on to the next presentation, we have R. Akash who will be presenting a systematic benchmark of segmentation models under data scarce conditions on CHD-CT volumes. You may now begin your presentation. Is Akash or any of his teammates present in the meeting? All right, so we'll move on to the next presentation and we'll circle back to this one later. Next up, we have B.R. Hariku Raju, who will be presenting Bridging the Reality Gap, a hybrid YOLO-efficient ad approach for real-time anomaly detection in unconstrained manufacturing environments. You may now begin your presentation.
Yeah, good afternoon, everyone. I'm Harika Raju, and I'll be sharing my screen. Just a minute. Yeah, can you see my screen now?
Yes, we can.
Yeah, so just a minute. Okay. Good afternoon, everyone. I'm Harika Raju, presenting on behalf of our team, Professor B. Manasa, Sunidhi, and Shrikriti from Keshav Memorial Institute of Technology. Our paper is titled Bridging the Reality Gap, a hybrid YOLO efficient AD approach for real-time anomaly detection in unconstrained manufacturing environments. So let's move on to the motivation as to why we went with this problem statement. Let me start with a picture. On the left side is a MBTech capsule, AD capsule, that is an industry standard benchmark dataset for anomaly detection. Uniform gray background, fixed camera, stable lighting, as you can see here. And on the right side, we have the same capsule, but now sitting under the shadows, stripe patterns, and uneven lighting, the kind of clutter that you would actually see on a factory floor. That gap between the benchmark and reality is the problem we set out to solve. Anomaly detection models today are almost always evaluated on datasets like MVTech AD, where they score beautifully around 90 to 95, 97% accuracy. But in reality, on a factory floor, it is not a photo studio. There's dynamic lighting, there'll be cluttered scenes, orientation will be different, there'll be vibration, and a lot of background noise. This is the background noise as we can see. Our research question was simple. Can we retain the real-time anomaly detection performance under the real industrial conditions? So before we go into the solution, first we'll go through the literature review. A quick look at where this field stands. First is the patch core. Patch core was developed around 2021. What it does is it stores a memory bank of patch level features taken from a normal training images and flags those anomalies by nearest neighbor distance at test time. It gives excellent localization accuracy, but the problem with the patch core was that it was making the memory bank very heavy and slow, which will be a very problematic for real-time deployment. Next, coming to PADM. PADM was also developed on 2021. This is the model that will model the whole normal feature distribution at every spatial location using multivariate Gaussian and scores those anomaly scoring by distance from that learned distribution. That means this complete model works unsupervised and needs no defect labels to train, but to develop and to train and to use it in inference in the inference time, the computing and the storing per location is very computationally expensive. So that is the second one. Coming to efficient AD that we'll be using in this paper as well. It was developed around 2023. It is a lightweight path description network, PDN, consisting of four layers combined with a student-teacher pair and an autoencoder, which is reaching around only 2 millisecond inference. That's all. But the weakness with this model was that our paper directly targets is sensitivity to the background clutter and environment variation. Fourth is the YOLO V8 that we have also used in the paper. Also, YOLO V8, the version V8 was developed around 2023. It is a single stage object detection, real-time object detector that basically with one forward pass, YOLO what it does is it predicts bounding boxes, confidence, and class together. It's fast and accurate at localization, but it was never built for detecting anomalies. It was more of a classification or extracting the ROI. So here's the gap. Every one of the models that I've talked about optimizes for benchmark accuracy in isolation. Almost no model combines localization and anomaly detection to close that reality gap with real life images and real life constraints. So our solution is this. Before I move on to the solution, I just wanted to give a brief about how the YOLO and efficient AD model looks. As you can see here in the YOLO model itself, it was detecting the objects in the image, and then this is how it works. And efficient AD, this is the architecture as to after an image is detected, the student network will try to replicate it, and whatever anomalies are there, it will show us it in the heat map. So the solution goes this way. The stage one is first the image will pass through the YOLO V8 model that is fine-tuned on the on the data set that we train on. Think of it as some single glance detector. As I've mentioned earlier, in one forward pass, it will detect the object in the frame, draw the bounding box, and hand off just that region in the image of the object that we want to detect anomaly in. So that is stage one. and we'll get the ROI. Second is the stage 2 is ROI processing. Before we send it to efficient AD model, it needs to be resized to 256 dimension pixel image. That is how efficient AD will take the image. Third stage is third stage is efficient AD. As to how it works is it has three cooperating networks. First is a teacher network, a small patch description network. It is already pre-trained on general purpose images. So the weights are frozen for it. So it will act like a general purpose expert on not what normal visual features look like. Second is the student network that is architecturally identical to the teacher model, but trained from scratch on our data. Basically, it will train. The catch is that this model will train only on defect-free samples. Think of it as a new employee who has only ever seen perfect products. So when it encounters a defect at inference time, it cannot produce what the teacher sees there. And that disagreement is our first anomaly signal. Third is an autoencoder. Autoencoder, what will it do? It will train on normal images as well that compresses and reconstructs the input. It will feed it a defective capsule, and the reconstruction will come out slightly wrong because it was trained on normal images in the first place. So that is our second signal of anomaly detection. So these are the four stages that it will go through. Normal efficient AD model, what it was doing is up until now, it was taking images that were trained only on MBTech dataset, as I've mentioned before, that with proper lighting, proper orientation, and everything. Our goal was to make sure that it will work in real time as well. So that's why we introduced this framework. Now, as you can see, this is the architecture walkthrough, the same thing that I've explained. YOLO will detect the object, and after the ROI is extracted, it will go through the efficient AD model. After efficient AD model will give us the final heat map. Heat map will contain the anomalies in the picture. All of it will happen in 2 milliseconds. If we use some Jetson Nano or Xavier Nano also, this will work very well with that kind of compute power. Now, experimental setup, how we have achieved it. So first we have used two data sets actually, that is MVTech capsule category data set as well as some industrial data set that contains all car images and unconstrained images. These were the data set that we have done. And to prove our hypothesis, these were the configurations that we worked with. First is efficient AD with MVTech that was there in the original paper as well. Second is the efficient AD with just unconstrained, that is completely cluttered images. Third is YOLO with efficient AD and unconstrained, that is car and defect, normal cluttered images. Fourth is our pipeline, that is YOLO, efficient AD and MVTech, but with background noise. We have added some background noise to the MVTech images itself to test the accuracy and to test how it works. And let's see the results. Results are these. This is the baseline that we have talked about, the same thing. The image AUROC was around 96%. The pixel AUROC was 94.5% in 2 milliseconds, that is latency. So that was the first baseline that was given originally in the paper. Second, we have tested with the unconstrained images, normal images. The accuracy reduced to almost, I think, 37.7 per point drop. As you can see here, it is 58.3. And third is YOLO plus efficient AD with unconstrained. That is, we have tested it with the YOLO efficient and with car industrial images. And as you can see, even though it didn't perform well with the actual unconstrained images, what it did was there was a jump from 58 to 63, as you can see, with this YOLO framework. Fourth is the one that we have worked with, that is YOLO plus efficient AD plus MVTech, but MVTech images added with background noise that gave us around same 96.2% increase in the percentile, that is 96.2 and 94.2. So with
Excuse
this,
me.
yeah,
I'm so sorry to interrupt. You have less than a minute left.
sorry.
You have less than a minute left.
Yeah, it's done. So these are the results that we have that have demonstrated. As you can see, this is the YOLO cropped image, and there's a scratch here in the image itself. As you can see, there's an anomaly and it has been detected. Here also you can see that there's 96% accuracy in detection. Conclusion. This is the final slide. And conclusion is that so bring it all to bring it together. benchmark performance alone doesn't tell you how a model will behave on a real factory. So this is where we have tried to bring it together, where are these models, these benchmark models can also work with real-time images with these pre-processing steps. That is the framework that we have established. So this is all about it. Thank you.
Hey, any case study which you have done on this?
Sorry?
Any case study or any application which you have, means a real-time application which you have identified on this or verified by using these models?
So real-time application was that these models originally were it was being used by Amazon as well to detect the anomaly part and everything. But as I mentioned before, it was being done on all perfect data sets only. The real-time application of this whole framework is that we can do it on images and data sets that are actually having background noise and everything. So that is the application of this whole framework.
No, that is what it is. On such application, have you cross-verified whether it performs well? That is what my question is.
Yes, yes, that is why I've shown the result table as well in the configuration where we have tested it with 4 configurations. One second. This is the result table. We have tested it with 4 configurations, and this is what we have achieved. So this is the verification that we have done up until now.
So on the same data set, all these things were done.
2 datasets. That is, one is MVTech dataset that is completely clean, completely without background noise, and one is with car data, that is some other background cluttered datasets. Third is with MVTech only, but with background noise. These are the 4 configurations. And as we have seen with unconstrained also, even though we cannot see that much accuracy, there is a jump from 58 to 63 when we have used YOLO. And in proposed with MVTech with background noise, it almost gave the same accuracy as we have done. So this is what we have observed. These are our observations.
Okay. Thank you.
Thank you.
All right. Now moving on to the next presentation. Next up, we have Sonali Samir Dhumal, who will be presenting deep learning-based fruit ripeness detection using image processing. Sonali, you may now begin your presentation.
Thank you. Sharing my screen. Is my screen visible?
Not
Have-
yet. Okay, it's visible now.
Okay. Good afternoon, everyone. I'm Sonali Dhumar. Today I'm presenting my research title, Deep Learning Based Fruit.
Sorry to interrupt. You are not sharing the presentation.
Actually, I have shared.
No, please reshare your screen. We can see your drive window, but we can't actually see the presentation.
Okay.
Yes, your presentation is visible.
Okay. Thank you. Uh, I'm presenting my research title, Deep Learning Based Fruit Ripeness Detection using Image Processing under the guidance of Dr. Anita Shinde ma'am. This work is basically focuses on developing an automated system that which classifies the ripeness stages of bananas and papayas using transfer learning with the VGG16 model. The main objective is to improve the fruit quality assessment and reduce the manual efforts, and it should support the post-harvest management. These are the outlines of my presentation. I will start with the introduction, then literature review and research gap. Then I will explain the problem statement and objective. Then we'll explain the methodology, and we'll show the result and analysis and conclusion with the future scope. Let's start with the introduction. Fruit ripeness detection is very important in agriculture as well as in food industry. It helps in maintaining the quality and it deciding the right selling time and reducing the wastage of the fruits. Then, in most cases, ripeness is still checked manually using visual inspection like color, texture, and sometimes using smell. But this method is not always suitable or reliable because the human judgment is may give different results. So when we deal with the large quantities of fruits, the manual inspection becomes difficult, and it is also time consuming and inefficient. It leads to incorrect classification, and it um, give the financial loss because of this. So with advancements of image processing, image processing and deep learning, we can have opportunity to automate this process. Deep learning models, especially convolutional neural networks, can learn the important features directly from images such as color, texture, patterns. So in this work, we are focusing on the developing the automated system that can accurately classify the fruit ripeness stages using deep learning techniques. Uh, Using deep learning techniques, and it gives the three different stages of classification, like ripe, mid-ripe, and uh, s- uh, not unripe. Uh, the motivation of this work is mainly comes from the limitations of the uh, current method. The first is like manual inspection. As I said, it is inconsistent. It depends on the human experiences, and it can cause the errors, especially while handling the large volumes of fruits. Second, there is advanced technologies like hyperspectral imaging, uh, which are very expensive and it requires the special equipments. And because of this, they are not suitable for small farmers and local markets. So there is a clear need for solution that accurate and affordable solution should be made, and deep learning provides a good opportunity here to mm, uh, it automatically uh, it automatically learns the features from the images and give the high accuracy, and also the models can be deployed on mobile devices, making them more practical. So the main motivation of this project is to develop low cost, automated and efficient system which helps farmers and vendors make better decisions and also reduce the food wastage. These are some literature reviews. Several researchers worked on the fruit ripeness detection using machine learning and deep learning. There are some CNN models which improves the accuracy. Uh, Most of the studies are conducted in controlled environments, and the studies form the foundation for these studies form the foundation of our proposed work. Most existing work is limited to laboratory conditions. Some traditional machine learning methods fail under varying lighting and background. Then high cost technologies are not widespread use. Then lightweight deep learning models are not sufficiently explored. These gaps motivated us to design the practical solution. Problem statement is to develop an automated fruit ripeness detection system, which should reduce the post-harvest losses and improve the quality. It uses the image processing and deep learning for classification. The main aim is to achieve the high accuracy across different ripeness stages. The objective is to study the existing deep learning techniques for ripeness detection, to design the efficient uh, feature extraction methods, and to develop a CNN based classification model to evaluate and compare the performance with existing systems, uh, and overall to create a reliable and practical solution. This is the proposed methodology. The workflow begins with the image acquisition from the public datasets. Images undergo pre-processing before being passed to the feature extraction. Uh, the pre-trained VGG16 network used for feature extraction. Finally, the model classifies the fruit into different category, and its performance is evaluated using standard metrics. This is the methodology explanation. The first step is image acquisition. The images are collected from datasets like I've used Kaggle and RoboFlow. And then fruits included fruits are banana and papayas. Then pre-processing includes resizing, normalization, background removal, and augmentation. Then feature extraction. CNN automatically extract the deep features like uh, color, texture, and shape. Then
Hello, I'm so sorry to interrupt. Excuse me. You have 1 minute left.
okay. Then this is the algorithm I've used, VGG16 and VGG19. These are the steps. These are the tools and technologies. Then I've used uh, datasets from Kaggle and RoboFlow, and basically the result classification accuracy is 98.02%. It demonstrates the excellent performance in distinguishing the different ripeness stages of bananas and papayas. In addition to accuracy, the model achieved high precision recall and F1 score, indicating the balanced performance across all the classes. Then this is the conclusion matrix correctly classifies across the main diagonal, indicating the high precision accuracy, and it classifies the semi-ripe, ripe, and mid-ripe. Mid-ripe. The overall confusion matrix validates the reliability of the deep learning proposed deep learning framework for automatic classification. And in conclusion, the research presents the deep learning based framework for automatic uh, ripeness detection using image processing, and classification accuracy is 98.02 along with the high precision recall F1 score, and it reduces the dependence on manual inspection, improves the consistency in ripeness assessment, and it supports the farmers, retailers, and food industry for making the better quality and control the decision making. These are the references I've referred. Thank you.
Madam, instead of using this VGG, why you have not used ResNet or something efficient net? Because VGG falls into CNN category only.
Yes.
Then why again you have gone for this VGG itself? Means any specific reason?
Not any specific reason. Actually, I have used efficient VNet, and accuracy is almost actually same, but in point it varies in point only. That 98.01. I have used that also algorithm.
Okay, ResNet you have not used, no?
ResNet not used.
Okay, fine. Thank you.
Yes. Thank you, sir.
All right, thank you so much. We'll move on to the next presentation now. Just a moment. Our next presenter for today is Pramukh Nima, who will be presenting Design and Implementation of an Orchestration Framework for Automated SQL Database Sharding using Static Schema Information. Pramukh, you may now begin.
Yes. Is it visible?
Yes, it
Hello.
is.
Okay, so my name is Pramukh, and today I will be presenting the paper titled Design and Implementation of an Orchestration Framework for Automated SQL Database and Sharding using Static Schema Information. So when we talk about the SQL database such as MySQL and PostgreSQL are widely used because they provide asset compliance, strong consistency, and structure schemas. However, as application grows, a single SQL database becomes a bottleneck because SQL database does not natively support horizontal scaling. But when we talk about the manual sharding, which is possible, but developers must manually select the shard key, route the queries, and synchronize the schemas, making the system difficult to maintain. So therefore, we proposed a system where we automate the orchestration framework that performs this task automatically while allowing applications to continue use standard SQL queries. So we also review some research paper on this. So first research paper tells about the integration SQL sharding using Apache Kafka to improve the distributed transaction processes. Although it improves the throughput recovery, it mainly focuses on transaction management rather than automation. And the second paper discusses horizontal and the vertical sharding strategies for improving the scalability and load balancing. The third paper mainly focuses on the balancing the workload, reducing data queues, and also assume that database has already been sharded. The fourth paper proposed the migration techniques for moving the database between shards with minimal downtime. However, it does not automate the shard creation or query routing. So, based on the research papers and from the studies, we identify the common gaps that existing research only focuses on individual problems such as migration, load balancing, or distributed transaction. Mainly, our work is to integrate all these operations into a single orchestration framework so that we can automate shard key inference, query routing, and shard management. So the problem statement is the traditional SQL database cannot scale horizontally by default. So as user traffic increases, manual sharding becomes increasingly complex for the and also become error prone. So as you can see, this is the implement approach that we are using. So let's on the left side first, the slide illustrate the complex workflow of our framework. Let's say for the DML query operations, YAML query operations are select, insert, update, delete. The SQL queries is first converted into abstract syntax tree. From the AST, we identify the table name and determines the shard key. And based on the shard key, we can then pass the shard hash function, and we can use a consistent hashing map query to correct the database. Now move on the right side. We can see the DDL query, such as create table or alter table. The framework extract the schema information from the foreign key or the table mapping, and then we use metadata over the shard key inference algorithm to automatically determine which shard key and update the shard metadata. At the end, the entire process happens automatically without require the manual configuration. So these are the core techniques that we have used. This is the key-based sharding that we have used. Every record contains a shard key, and the shard key passes through an hash function, and then the hash function resulting in the hash value determining the which shard shows that particular record. This is the abstract syntax tree. Uh, so before routing, the SQL statement is passed into AST, and the parser extract the table name column, where condition or joins to determine which area should the query should go to. Uh, at the bottom, we can see the formula for the consistent hashing. We compute the hashing of the shard keys and place it on the hashing and record the first shard whose hash value is generated and then equal to the keys. And if no shard exists, the request wrap around and the first shard goes on the ring, and the minimize the data movement when new shards are added. These are the results. This is throughput versus concurrency. So the first graph shows the throughput. Throughput remains relatively stable for 1 and 2 shards, but as we can see, the the demonstrative effectively request distribution. The second graph shows mostly the P95 latency. Although the latency increased with a higher concurrency, the increase remain manageable and indicate the framework is scalable effectively under the heavier workload as well. This graph shows the two shards provided, the best balancing between the scalability and communication overhead. As more shards are added, we can see the coordination overhead slightly reduced efficiently, and this is the tail amplification graph. The lower the value indicates consistent response time. Overall, our framework maintains stable latency across the different concurrency level. This is the heat map. Over the dark green area represent the higher performance score, while light color indicates reduced performance. As expected, the performance gradually decreases as the concurrency increases. Overall, the framework maintains good performance across different configurations. This is the whole system architecture that we would be following. This is the user application, which will be run locally from the user side. At the bottom, you can see the user application, and the remaining is the repository list, which stores the metadata, such as the schema information, event in metadata, and project metadata. This is the service layer where most of the thing is done. The service layer is the core framework, which contains the query parser, query router, query executing, which handles the key inference module, connection manager, and many other that. And rest is the application layer, which expose the API and the R services. In the top, you can see the multiple database shard which are stored differently, partitions of the data. And this middleware coordinates the communication between the whole application and the user's database as well, which allow developers to continue use normal SQL queries for the SQL database. So on the conclusion, I would like to propose that an automated framework for SQL database sharding. The framework automates the shard key selections, query routing, schema synchronization, and shard management, which reduces the developers' efforts in future work. We plan to support a dynamic workload and distributed transaction as well. Um, Thank you.
Can you tell one major findings from your this work what you have followed?
Major finding that existing solution requires a manual configuration, let's say for shard keys and routing. But our framework automated these tasks through a middleware layer, making a SQL shard is easier to adopt without changing the application's query.
Okay. Any effect of this into on the result?
Well, mostly the sharding is done on the user side. Mainly, they develop the old uh, application, but we have automated this, so it makes easier for the companies whose infrastructure are deployed by them, not using any external AWS or cloud services.
Mm-hmm.
So yeah,
Okay. Thank you.
thank you.
All right. We'll now move on to the next presentation. So next up, we have Ritu Arora, who will be presenting Mediating Effects of Job Satisfaction on the Impact of Internal Marketing on Employee Turnover Intentions. You may now begin your presentation.
A very good afternoon to all. Am I audible to everyone?
Yes, you are.
Okay, ma'am. I am sharing my screen. Let me know if is my screen visible to all of you?
Yes, it is.
Okay. So a very warm good afternoon to all of you. Today I am presenting my paper titled Mediating Effect of Job Satisfaction on the Impact of Internal Marketing on Employee Turnover Intentions. My other colleagues are Azmi Zahir and Sakshi Khetrapal. So this is the paper that I am presenting. Let's start with the introduction first. If any employee leave any organization, it create a loss for their human capital, and this subsequent damage create problem for everyone, and this is due to the fact organizations are investing a lot of money in the education, training, development of their employees, their career development, so that they are able to get optimal productivity and efficiency from them, and the loss of valuable workforces leads to the loss of skills and experiences that also create an negative impact on our productivity. So the role of committed and devoted employees is very important in getting the consumer satisfaction, as employees are one of the most valuable asset for any organization nowadays. Job satisfaction is the traditional way how we are retaining our employees. But nowadays, organizations are investing a lot of money in internal marketing strategies as well. So job satisfaction influences the employee turnover ratio, but the internal marketing is also playing a big role in the service sector to retain the employees. Private universities are in India is expanding every day, which also pose a serious threat to Sholini University. So the Sholini University prioritize their internal marketing in the form of welfare, education, salary, communication, and so on, so that they are able to influence their employees' intention to leave their current positions with job satisfaction as a mediator. So this research fills the previous gap. So this research fills the previous gap by examining the effect of internal marketing on job satisfaction and turnover ratio, where the job satisfaction work as a mediator in the Shulini University, as we have taken in Himachal Pradesh, India. So this is the literature review that we have done. We have taken almost 50 to 60 papers for reviewing the literature. These are the important papers that we are displaying on the screen. The term turnover ratio, in which Tabassum et al. 2023 shows how turnover ratio, what is the meaning of turnover ratio, which elements are affecting the turnover ratio. So this is the important paper. Bag also says job satisfaction is a central construct in human resource management. So we have also collecting these paper so that we are able to find the research gap. So this is the proposed methodology that we use. This study employs descriptive survey methodology for data collection and this so that we are able to achieve our objectives. 1,200 employees working at Shulani University was approached to fill up the questionnaire, and that also makes up our population in this study. A convenient sampling is used for this purpose, and a grand total of 300 surveys were sent out. But only 250 people would be an adequate representation. So the final survey that we have collected is 260 respondents, and we did the analysis on that. For that purpose, a 26 question standard questionnaire with a 5-point scale, Likert scale from very disagree to very agree for reliability and validity check. And organizational internal marketing is measured using a 15 set of questions. Internal marketing is using 5 dimensions that represent the internal marketing, that is education, communication, welfare system, benefits, and managerial support. Each dimension is represented by 3 questions, and these 6 questions designed to understand or to measure the job satisfaction, and 5 question mean to 5 question items are used for employees turnover intention. This is the conceptual model that we are working on. First one is internal marketing is represented by training, communication, welfare system, managerial support, benefit and rewards, and internal marketing, job satisfaction and turnover intention. These are the hypotheses that we tested in this study. That is, first hypothesis is job satisfaction is significantly and positively influenced by internal marketing. The turnover intention of employees is significantly and adversely affected by job satisfaction. The impact of internal marketing on employee turnover ratio is mediated by job satisfaction. So these are the that we used. For reliability and validity check, we first of all check the Cronbach alpha. The Cronbach alpha for internal marketing variable is 0.927. For job satisfaction, it is 0.911. For turnover intention, it is 0.86. And the study, all the research variables are above 0.7. That suggests that there is a reliable, these questionnaire items were reliable. So the validity test. Validity test, for that purpose, we have done the confirmatory factor analysis was used to calculate the research validity, and chi-square test was done on the variables. All the values of chi-square test is above the permissible range, that is less than 3. So internal marketing is 2.11, job satisfaction is 2.27, and turnover intention is 1.19. Along with this, we also calculated the goodness of fit index, adjusted goodness of fit index, normalized fitted index, relative fit index, and all these other all these other tools, so that we are able to confirm that these are the variables or items are rightly measure the variable, latent variable. So this is the result of demographic. This is the demographic of respondents, that in our data set 147 were male and 113 were females. Below 30 years, there are 48 respondents. Between 30 to 40 years, there is 82. Between 41 to 50, there is 97. And above 50, there is 33. And teaching experience of the respondents below 5 years is 64, between 5 to 10 is 72, between 11 to 15 it is 86, and above 15 years it is 38. So this is the final model goodness of fit. Model fitness that explain that our model has good explanatory power. That's why this is the whole model goodness of fit index that we calculated. The study utilized second order confirmatory factor analysis to determine goodness of fit and examine the model of structural equations. And for that purpose, we used smart PLS here. The goodness of fit metrics can be considered satisfactory when 3 out of 4 variables are favorable. The overall
Excuse me.
model of
I'm so sorry to interrupt. You have a minute left.
okay, ma'am. So this is the results, and this is the final result where the hypothesis is confirmed and significantly affect each other. Internal marketing has a significant impact on job satisfaction. Job satisfaction has a significant impact on turnover intention. And there is a partial mediation between job satisfaction is partially mediated the internal marketing and the relationship of internal marketing and employee turnover intention. So this is the figures that confirm their mediating. So these are the research findings that our research investigation indicates 5 dimensions of internal marketing that were introduced a comprehensive understanding of multi-dimensional internal marketing concept in Indian education sector. The result of hypothesis first demonstrate that internal marketing has a positive impact on job satisfaction and confirming that implementation of these programs can be a successful strategy for enhancing the commitment of employees. The result of testing hypothesis 2 also confirm that turnover intention has a negative impact on job satisfaction. So lower level job satisfaction have been demonstrated by researchers to result in a desire to pursue new companies and leave intention. Based on the result of job satisfaction acts as a full mediator between internal marketing and turnover intention or employees plan to leave. So this is the results that we worked on, and this current study, as we already know, looked at the impacts of internal marketing on job satisfaction and turnover intention in the education sector in India. So since these are the main measures of organizational performance, according to the concept put forward in this, employees' perception of companies' internal marketing significantly impacts the job satisfaction, which also impacts their intention to leave the organization. So this is all about our study. Thank you so much.
Ma'am, how you have taken the benchmark values?
Okay, sir. These values are used. We have
These
used the
values.
procedure of smart PLS.
Okay.
Here at all, here Joseph here is the main resource or the books published by him on smart PLS that we have. From there, we have used the criteria to understand whether this value is confirmed or not.
Okay, fine. Thank you.
Yes, sir. Thank you so much.
Thank you. We'll now move on to the next presentation. And next up, we have Roshan Malkar, who will be presenting performance evaluation of Socket.io broadcast versus CRDT synchronization for real-time collaborative code editing. Roshan, you may now begin your presentation.
Share my screen. Is my screen visible?
Yes, it is.
Okay. So good afternoon, everyone. Today I am Roshan Malkar. Today I will be presenting our research in performance evaluation of socket broadcast versus CRDT synchronization for real-time collaborative code editing. So this research is carried out under the guidance of Professor Sujata Ambekar along with my teammates Sujal and Vaibhav. We are from Department of Computer Science, Ferguson College. So let's begin. Yes, so moving to the so before starting with the research, let's just understand what is the real-time collaborative editing. So uh, there are multiple applications like the Google Docs and there are online platforms, so code editor platforms, and like Notion. These platforms allows multiple users to edit same document at the same time from multiple devices. So that is basically the real-time collaborative editing is. So the main biggest challenge that this collaborative editing platform faces is that the maintaining consistency while ensuring the low latency. So to achieve this, there are multiple synchronization techniques available, like the operational transformation, CRDT, the conflict-free replicated data type, and each of them have trade-offs between performance, consistency, or communication overhead, etc. So, in the literature review, we found that there is extensive study done on the CRDT and OT techniques, and uh, comparative studies done on on CRDT and OT, but very few studies have directly compare socket-aware broadcasting versus the CRDT synchronization under identical experimental conditions. So that's motivated our research. Uh, Moving to the research objective, the main objective of our research is to experimentally compare the performance of these two models, that is the socket-based broadcasting model and the CRDT-based synchronization model. So to achieve that, we developed two collaborative editing prototypes. For in that, we first implemented the socket-aware broadcast synchronization prototype using socket-aware and WebSocket communication. And second, we implemented CRTT synchronization prototype using YJS framework. Then we measured and compared key performance matrices like the propagation delay, update size, memory users, document size. We'll talk about this performance metrics in later slides. And at the end, we analyze the trade-off between the performance and the consistency to understand which technique is better suited for which type of applications. Mm, Let's briefly talk about the models that we implemented. So first, on the left hand side, we have a socket broadcast. In this diagram, we can see it follows the star topology. Like there is a central server, and the users are connected to that server. So whenever a user performs a meaningful operation or edit something in the document, that change first goes to the server, and the server transmits that change to the other connected users. So in this, the entire document is transmitted during each edit. And the advantages of this software workers is that it is simple to implement and it gives low latency. So the drawback is there is no built-in conflict resolution mechanism in software. Now moving to the second model, that is the CRDT. In this diagram, we can see that it follows the mesh topology. Like all the users are connected to each other directly. So whenever a user performs a meaningful operation, that change goes to directly from current user to all the connected users. And in this, the delta changes sent during each change. So if a user performs a change, that only that change is transmitted to the other users, not the whole document as the socket does. So and in a CRDT, the conflict CRDT has built-in conflict resolution, and the only drawback about CRDD is that it uses extra metadata for the conflict resolution, which is the overhead for the CRDT, and it is more complex as compared to implement as compared to the socket. Now coming to the testing architecture and experimental setup. To keep the comparison fair, we use same technology for front end and back end. So for front end, we use React.js and Monarch editor, and for back end, we use Node.js and Express.js. Only the communication mechanism is different for both the models. So for Socket, we used with socket communication, And for CRDT, we use YJS framework with a signaling server. So for the experimental setup, we set up identical user interfaces for both the prototypes. Then we tested this on the local network, and for the testing, we use 3 to 4 concurrent users, and the data logging, the data that we use for the analysis is logged automatically in that prototype itself. So, which is timestamp based, and it is exported in CSV format for the analysis. Now, the performance matrix that we use for comparison is the propagation is the propagation delay. What propagation delay tells us is that the how much time does required to transmit the change from one user to the other users. And the second one is the update size, how much data gets transmitted during each edit. And third one is the memory uses, how much memory each model uses from in the front end side, like during the editing session, how much RAM gets consumed by each model. And the last one is the document size, the internal size of the synchronized document, how much size it takes for both in both the prototypes. And all of these metrics are collected automatically during the editing session itself. So these are the experimental results. On this document, on this diagram, on the top left, we can see the average propagation delay graph. The blue bar graphs are for socket IO prototype, and the orange bar graphs are for CRDT. So in the first comparison, we found that the for the propagation delay, socket IO takes around on an average 1.4 milliseconds of time to transmit changes. On the other hand, the CRDT takes around 2.2 milliseconds of time. So this shows that the socket IO is much more faster. That is, it gives low latency. Then the second is update size. For socket IO, the average update size is 280 bytes, and for CRDT, it is much less. That is the 120 bytes. Because the CRDT it transmit only the delta change during each edit, and the socket IO transmit the entire document. So that's why it is differ. The third comparison is the memory uses. So Socket IO uses around 3 into 10 raised to 7 bytes of memory, and that's RAM. And the CRDT uses 3.6 into 10 raised to 7 bytes of memory. This CRDT uses more memory because it performs calculations for while merging the changes, the delta change. To merge that, it needs to perform some processing. So that's why it uses the more memory. And the last one is the document size. So Socket IO uses a fairly less memory size, that is 300 bytes only. And CRDT uses takes around 22 kilobytes of document size. That is because the during each transmit change, it takes it shows the metadata about each change. So eventually it goes on increasing for the CRDT models. So that's the results. Uh, Coming to the conclusion, so Socket.io is best suited for the lightweight collaborative applications where the small collaborative teams and small number of users are there, and where the low latency is required, and fairly simplicity is required. In that case, we can use the Socket.io. On the other hand, the CRDT is best suited for the large scale applications, like where the concurrent editing is required and consistency is critical. In that scenario, CRDT is best suited. So overall, final takeaway is that there is no universal winner. So it is totally depend on the developer to choose this technique. So it depends on developer should analyze the requirement and should decide which approach to go with for the technique for the synchronization technique to use. That's brings me to the end of this presentation. So in the future work, we are planning to implement the third synchronization technique, that is operational transformation OT, and test this in real time network environment. So currently we tested this in local environment only. So we are planning to test this in real world network. So that's brings me to the end of this. Thank you. Any questions?
Thank you. No questions.
Okay, I will stop my presentation. Yes. Thank you.
Thank you.
All right. We'll now move on to the next presentation. Our next presenter for today is Yatin Gupta, who will be presenting Smart IoT System for Soil Nutrient, Moisture Monitoring, and Early Fungal Risk Detection in Mulberry Cultivation. You may now begin your presentation.
Okay. Okay, so good afternoon, everyone. My name is Yatin Gupta. I am an electrical electronics engineer from Amity University, Lucknow campus. My topic will be a smart IoT system for soil, nutrient, moisture monitoring, and early fungal risk detection, basically specializing in mulberry cultivation. So what my project actually does is it combines IoT and image processing to monitor plant health. Leaf image is captured and processed in MATLAB to detect diseases based on visual symptoms. At the same time, environmental parameters such as soil moisture and nutrient levels are also monitored. So let's just do a basic introduction about this. In agriculture, agriculture is a major source of livelihood in India and it plays a very crucial role in the economy. The mulberry plants are widely cultivated for sericulture and textile industries, and mulberry leaves are the primary source of food for silkworms. The quality of mulberry leaves directly affects the silk yielding capacity of the silkworms and the silk that is extracted from the silkworms. Leaf diseases such as fungal diseases and leaf spot diseases reduce the quality of the leaf, and it can also reduce the quality of the textile that can be extracted from the silkworms. So the main problem is that what usually happen in mulberry farms is that thousands and hundreds of thousands of mulberry plants are planted in acres of land. So it makes manual inspection of every plant very difficult. And early stage disease symptoms are difficult to detect with the naked eye. And delay in disease identification leads to poor leaf quality, reduced silk production. If you don't detect the disease on time, the disease can spread and it can damage a big portion of your entire crop field. Therefore, an automated system is required for the reliable detection of mulberry leaf diseases. So the main objective of my project is that to develop an image-based method for detecting leaves symptoms on mulberry leaves and to analyze mulberry leaf image processing and MATLAB image processing techniques. It is a very fast and very direct and very simple method to identify whether the plant is diseased or not based on both MATLAB image processing techniques and the actual IoT sensors that are planted on the field. So this is my architecture of the overall system. In this you can see that the soil sensors are sending value to IoT module and to the disease image system and the image. This image is captured. It can be captured. It is captured from high resolution cameras and it is sent to MATLAB. And both of the information that is coming from the MATLAB and the IoT sensors, both of these information compile with each other and together they give a disease alert system. They give a notification on the users and that this portion or this particular plant in the field having a disease, is under an infection. So the methodology is mulberry leaf image is captured and given as an input to MATLAB. Image processing techniques are used to enhance the feature. Background is removed. Diseased areas are segmented using color and spot analysis. Infection percentage and disease severity are also calculated. We also use uh, RGB to HSV conversion to determine the disease to increase the accuracy of the image compilation accuracy. So as you can see, the middle here is the original image that is captured from the camera. When this image is uploaded to MATLAB, MATLAB here remove all the noise, all the background. It separates all. You can see this black area. It separates all the background. On the third, you can see the leaf without background. It removes all the background so that the uh, program and the software does not confuse it with. So it just sorted the area that have to undergo analysis. Then you can see step 4. You can see this small white dots. What are these dots? These are basically, if you look at step 3, these are basically leaf spots that are coming out. And the step 5 is disease leaf. It gives an output that yes, this area are diseased. You can see the red markers, red color markers. So it indicates that these are the regions on the leaf or these are the regions on the plant that are diseased. You can see here another image. This is an original image. First, it is converted from RGB to HSV. What RGB? RGB is the actual image value. This is good for visual presentation. RGB stands for red, green, and blue. And this is an HSV image, the black and white image. What actually helps? It actually helps the computer to analyze. It does not affect the light intensity, the color brightness, the shade of the color to affect the computer's judgment. And after you can see that leaf with the background, now the background is removed from the leaf. After that, you can see that only the leaf area is given where the disease is detected. So you can see the final result comes that severe diseases were detected. Now this is only the image processing part of my entire project. Now comes the hardware section. In this hardware section, I use ESP8266 and 7-in-1 soil sensor to detect soil nutrients. You can see here the soil sensor. It detected nitrogen content in the soil, phosphorus content in the soil, potassium content in the soil, and soil moisture content in the soil. It also gives you date. You can see these sudden spikes and sudden drops. What it actually tells is that when a plant is diseased, it also affects the soil around it. The original, you can see there is a big variation. Normally, it is 80 to 70. Somewhere this is the normal range. But if the plant is diseased, then it can give a sudden drop and sudden rise in the plant. Sudden drop and sudden rise. So this change in the value, it gives a computer an overall idea that there is some abnormality in this particular section of the land. There is some abnormality in this or that particular section of the land. So the results were simple and MATLAB successfully processes the plant images. All the background was removed, noise was removed, disease regions were segmented using color and spot features. Infection percentage is calculated for disease severity and output displays result. My model had an accuracy of about like 85, more than 80% of accuracy. And there were some challenges, like I said, the variation in lighting affects the color based segmentation. That's why I did RGB to HSV conversion. This is the main reason because of which RGB to HSV conversion was needed. Healthy leaves with high saturation may be misclassified, and background noises also influence the infection percentage. And algorithm performance depends on the image quality. So, as the image processing, you need to use high resolution cameras. But even if the camera quality is a bit low, there is still like almost 70% of the chance that the output you're gonna get will be correct. So 70% accuracy is the bare minimum. Even if the image is of poor quality, then too you will be getting at least 70% of correct result. It is currently tested on limited mulberry leaf samples. That's right, because the data set that I was using, I personally created it for myself, and that data set barely had like 400 images only. The future work that I plan to do on this project to improve it is that improve the background removal technique. Like I was planning on using ResNet and AlexNet pre-trained models to increase its accuracy from 80% to 95 to 98%. I also wanted to train the system using machine learning models, increase the data set size for better accuracy. Like right now, I'm using 450 images approx, and in future, I want the data size to be at least of 1,000 to 2,000 images, and extended detection for multiple plant diseases and integrate real-time disease detection with IoT platforms. What are the applications of this current model? So it helps the farmers to early detect the plant diseases and to help them to whether they should remove the plant or they should cure it by giving them pesticides, and smart farming and precision agriculture system is used in it supports system for farmers and research and integration with mobile and cloud platforms. You can monitor the disease from both your system and mobile. So the I would like to conclude that a MATLAB-based leaf disease system is under development, and image processing techniques were used for disease identification. System can estimate infection percentage and disease severity with a moderate accuracy. Current results show promising performance with a scope of improvement. Thank you. Are there any questions?
Yes. How you have measured the accuracy? Can you tell?
Sir, I manually measured the accuracy. Like I was uploading
Manually,
450 images.
how you can measure the accuracy?
Yes, sir. You out of 450 images, how many images were giving false trigger to the system? So, like in my case, about
Is,
like
is,
17 or
is this, suppose you want to use it for large scale, is this a feasible method to measure accuracy manually?
no, sir. At large scale, sir, you can measure the accuracy using pre-trained models like ResNet and convolutional neural networks
Then
that
why you
support
have not measured?
machines. Sir, because the main reason of this is that CNN and SPM, sir, they increase the complexity of the system. It's sure that they increase the accuracy too, but they increase the complexity. And at this time, that we were only able want to detect the leaf diseases only. That's why, and it can be done by MATLAB image
Accuracy is
processing
none of your
technique.
concern. Accuracy is none of your concern.
Sir, it is of concern, but I was already getting like 80% or 85% of accuracy. So
Okay.
it's not too good, but sir, it gets the work done.
Thank you.
So in future scope, I have written that I will be using CNN and SPM
Okay.
to
Thank you.
increase the accuracy even more.
Okay.
All right. We'll move on to the next presentation now.
Arisha ma'am,
And
how many presentations are due?
there are 2 more presentations left, and we'll circle back to a presentation that we had missed if the author is present.
Okay, fine. Thank you.
All right, thank you. So our next presentation is Kunj Moradia, who will be presenting transponder-free emergency vehicle preemption and adaptive signal control for heterogeneous Indian urban traffic using DQN and YOLO V8. You may now begin your presentation.
Thank you. The screen is visible. Please confirm that.
Yes, it is.
Okay, thank you. So, good evening, sir. My name is Kunj Moradia. I'm the presenter for this the paper traffic signal time prediction. With my let's directly jump to the problem definition. And so, before I go any further, I want to hold one number in your head, which is at 27.5 seconds to 2.4 seconds. It is an ambulance at a signalized Indian intersection of weights, 27.5 seconds. And my results shown that it can wait to 2.4 seconds only. So let's move on further. Why do these problems exist in the first place? Walk up to any Indian intersection and you will see the issue immediately. Two-wheelers, cars, auto rickshaws, and buses all sharing the same lane with no real lateral discipline. Fixed time signals were designed for a much more ordinary traffic streams, and they simply can't adapt to this mix. The deeper problem is that green time, once lost, can never be reclaimed. Every wasted second compounds across thousands of cycles a day into cost and emissions. Vehicle indiscipline plus highly unpredictable arrival patterns defeat any pre-computed fixed cycle plan. But the part that matters the most is when an emergency vehicle gets stuck at a red light, this isn't an efficiency problem anymore. It's a life safety problem. Our case study is a real surveyed intersection, Iskon Cross Road in Ahmedabad, using the industry recognized sumo simulator. So everything I show you today is grounded in real geometry, not a toy simulation. Let me see through the gap. Why existing approaches fall short. For existing approaches, 4 different walls inductive loop detectors are costly to install and maintain, and they implicitly assume a homogeneous vehicle stream, which is not in Indian case. Which, as we just saw, Indian traffic simply isn't. Scoot and SCATs are proprietary, loop-dependent systems. You can't even benchmark them in one simulation. Transporter-based preemption needs hardware fitted on every single responding vehicle. That's not scalable across India's fleet. And even prior work that combines cameras, the reinforcement learning still routes detector output through handcrafted switching rules instead of learning the policy directly. It's that nobody has closed the loop from camera to learn control end to end without extra hardware. So that's a gap I have found, and I propose my solution. That's exactly the gap we close. In prior work, a YOLO detector feeds handcrafted rules, which feed a controller. That's a human design layer sitting in the middle. In our paper, YOLO V8 detection feed directly into the reward signal that trains a DQ in. That's a deep queue network. We remove that handcrafted middle layer entirely. And here's the elegant part. That same camera stream that powers adaptive control also enables transporter-free emergency vehicle detection. One sensor, two jobs. Everyday adaptive signal timing and emergency override with nothing extra bolted onto any vehicle. This is the layer architecture. I will explain through another demo, if you may allow. So this is the basic YOLO V8 detection, how these bounding boxes are working in this. That is already explained by another presenter. The most important part is the decision layer. We input, basically this is a two-way intersection, not like northeast and south, like north and south and east west. This is the direction 1, direction 2, Q, and this all things. I have designed the network which has 128 hidden neurons with two hidden layers, and ReLU that has implemented in that layer. In the output layer, only 5 neurons, and which is include only linear. So in the system design, first my solution will detect the vehicle from the YOLO V8 model. Then a vehicle is detected after the DQN network will work and give the optimal green time duration. and controls other things as well. This is one experimental setup that I worked with and pro provided the results in the paper as well. 5 baseline competitors I've used: Webster fixed cycle, fuzzy logic, genetic algorithm, PSO, and graph neural networks for the comparison. And my solution, the YOLO V8 plus the deep network, tested on the ISKCON Crossroad Ahmedabad with the 5 scenarios: normal, peak hour, emergency, vehicle scenario, rain, fog, and night. Results are which can uh, which will be measured that through the sumo simulator. 13.6 delay cut that normally demanded, 16.8% delay cut during the peak demand, and up to 7.25 to 8.3% throughput gain through my solution, DQ and the YOLO V8. As you can see, the 91.3% faster clearance in compared to the Webster's fixed time, which my solution given me by running the in Sumo simulator. There is one weak point in this research paper. Auto rickshaws are the hardest class in every condition. Around 86.9% in rain due to the irregular lateral placement and the partial occlusion of adjacent vehicles. This class level weakness doesn't propagate to control degradation. So this is the loop, the closed validation, real-time camera pilot, the multi-intersection scaling, and the inclusive state. This is my future work. I have implemented at one signal, then multi-intersection connectivity will be there as my future work.
Excuse me, I'm so sorry to interrupt. You have less than a minute left.
Okay, so thank you. Why vanilla DQN is only the solution that I've used. We prioritize the simplicity and training stability to get a first working closed loop controller end-to-end. Newer variants cited in related work are a natural low-risk next steps once the base pipeline is validated on real camera data. Why this matters for sustainable urban mobility. So why should sustainable mobility researchers or city planners care about this? 4 reasons. Zero new roadside hardware. This runs entirely on CCTV infrastructure Indian cities already operate. Its genuine road safety outcome. Faster emergency response means lives, not just throughput numbers. Delay reduction compounds across cycles into real, measurable fuel and emissions saving at scale. And because it's deployable across the large fraction of intersections that already have surveillance in place, not just brand new installation. I will leave you with this. The 13 to 70% delay cut in compared to Webster method. That's how my research have achieved 91.3% faster emergency clearance and 41 millisecond end-to-end control latency in according to zero new roadside hardware that I've used, like the transponders, which are available in the ambulance. Thank you.
No questions from my side. Thank you.
Thank you.
All right, so we'll move on to the next presentation now. Our next presentation for today is by Ali Asghar Masood, who will be presenting Voice-Based Cognitive AI Companion. You may now begin your presentation.
Is my screen visible?
Yes, it is.
Okay, thank you. Good afternoon, everyone. I'm Aliasgar Masood, guided by Dr. Hariram Chavan, and this is our final year project, a voice-based cognitive AI companion. The idea is in one line. What if you could manage your entire inbox and calendar just by talking to an AI companion on Telegram? Right now, we know in this booming era of AI, everyone uses GPT and Claude and other models, but they basically use it as a question and answer machine. We actually wanted to make something that daily users, like the mass people, can use and actually save their daily time and use it more fruitfully. You've probably already seen where AI is heading. Agentic AIs are in the news constantly, doing all kinds of jobs on their own. So we didn't want to build just one more tool that answers questions when you ask it. We wanted to ask a different question. Can AI actually save you real time in your day? So let me quickly tell you what we actually built. It's a multi-agent AI companion deployed on Telegram, and you can talk to it normally, like a conversation. Ask it anything, and it can even research the web for you. And it reads and summarizes your emails automatically. It can also send your emails by you just saying a voice note like uh, greet this person and just mentioning its email ID. And if you tell it to set up a meeting or a reminder, it handles your calendar too. Here's why that actually matters. I saw this firsthand at my own college. Teachers get flooded with emails. A student misses a lecture, sends a long explanation of why they were late. Then 4 or 5 more students send the exact same kind of email. And the professor has to open each one just to figure out who was actually absent and what was the reason. With our companion's email summarization, the professor sees at a glance exactly what each email says without 20 of them one by one. They don't have to read each and every email. Just as important as what it does is who it's for. Our main goal was to make this genuinely user friendly for mass everyday users, not just technical people. And basically, the idea for deploying it on Telegram was that the friction would be very less to actually use this kind of thing. There's almost zero friction to get started. No new app to download, nothing unfamiliar to learn. Just message it like you'd message a friend. That includes scheduling too. A lot of people find even opening Google Calendar and filling out a form a hassle just to set up a meeting. Uh, so in this cognitive AI companion, you just say set up a meeting with this analyst in 2 hours, or set up Google Meet with my friends and also email them about it. And the AI will do that exactly. That's the real motivation. AI that's easy enough to use for anyone, and that's actually giving people back their time. Uh, that maps to 4 concrete problems. Email handling is manual and repetitive. Every message needs to be read and judged individually, exactly like the example I just gave. Setting reminders or labels means digging through cluttered menus. We have to open our Google Calendar every day, and that is probably the main reason why a lot of people do not use Google Calendar. It's like a hassle of opening the calendar and setting up your email or setting up a meeting reminder every time. But using this, and it actually creates a real cognitive overload by doing that. But by using this agent, you basically just type in that create a meeting with Mustafa or something like that, and you don't even have to type. You can basically, the main idea is to use your voice, like to just talk. Before building anything, we looked at the research. Speech recognition tools like Whisper are already highly accurate models. Like GPT and Gemini can summarize and draft coherently on its own. What's missing is anyone combining that with calendar automation in one unified system. Looking at what already exists, Google Assistant and Alexa handle voice well, but don't touch your inbox. Gmail Smart Reply and Outlook Copilot generate AI text, but you still have to type or click to use them. Basically, a lot of people nowadays like tell Google to GPT to generate an email, and then they copy paste it just to write the email and all that. But we wanted to make it a one-click experience. None of them combine voice, email intelligence, and calendar automation in one place. That's exactly the gap our system fills, as you can see across every column here. So our objectives follow directly from that. Understand and execute natural voice commands, summarize emails, and autograph replies. Apply smart labeling, manage the calendar by voice, and deliver all of it through one familiar interface, Telegram, instead of another app to install. That is our main reason for using Telegram. In practice, that becomes 7 functional modules. A Telegram voice note is the single point of entry. From there, the system summarizes emails, draft replies, applies smart labels, filters your inbox, manages calendar events, and sends results right back inside the same chat. Like whatever you say that send an email uh, greeting this person and inviting him here. So the AI agent will actually it's a multi-architecture AI agent. But basically, the AI agent will perform the task and then reply you with an email that I've sent an email and I've said this. And even if the agent does not understand what you're actually trying to tell, it will ask you before sending the email that, okay, I'm sending this text in the email. Is that okay with you? Here's how it's actually built. First of all, in our starting phase, we were actually just using a single agent, and we had a big system prompt in it, and use the Gmail agent when it feels, and the calendar agent when the user intent is to set up a meeting or something. But in that, we found that the agent was hallucinating a lot, and it wasn't actually following the process accurately. The accuracy was around, I'd say, 60%. But and to increase the accuracy with just a single agent, we we had an option which was not feasible, but it was to use a very high complex model. Like in GPT, we could use 4.1 mini for with this multi-agent architecture, but we actually had to, for a single agent, we would have to use a much higher and complex model, which would actually cost a lot more. So through this multi-agent system, we've designed a manager agent. Every query that the user types goes to the manager agent, and it classifies the query as, is it just asking me to search the web, or is it just asking a basic question or answer or something like that, or is it actually commanding me to send a Gmail or summarize today's emails, or maybe set up a meeting in the calendar or something. According to that, if the task is to send a Gmail or something, it directly routes the query to the Gmail agent, giving it a summarized query of what the user intent actually is and what it should perform. Based on that, the Gmail agent then connects with our Google Gmail, and it performs the task, and it then gives a feedback to the manager agent of whether the task was performed, or if there was an error, if it needs more information, like that. And the manager agent then connects with the user. The main agent that is replying to the user and interacting is only the manager agent.
Excuse
This
me.
increased our accuracy a lot more.
Excuse me, I'm so sorry to interrupt. You have 1 minute left.
Okay. This isn't just a design on paper. On the left, sorry. The project follows the agile model, iterative sprints and continuous testing. That is what we've used entirely while building this. And technically, the agents are built with LangChain using GPT and Whisper via the OpenAI API. Telegram, Gmail, and Google Calendar are connected as integrations. Superbase handles the storage, and it's self-hosted on my own VPS on the Contabo servers. To conclude, this shows AI can move beyond just answering questions and act as a genuine personal assistant, understanding what you want, reasoning about your inbox, taking action, and verifying it actually happened. It's hands-free, it's a real multi-agent system, and it lives entirely inside a chat app people already use. Thank you. Are there any questions? Hello? Am I audible?
Yes, you're audible. Nilesh sir, do you have any questions?
No, ma'am. No, ma'am.
All right. In that case,
Next.
we'll circle back to the next presentation. Next up, we have R. Akash, who will be presenting a systematic benchmark of segmentation models under data scarce condition on CHD-CT volumes. You may now begin your presentation.
Hello, am I audible?
Yes, you are.
Okay. Let me just share my screen. Okay, is my screen visible? Hello.
Yes, it is.
Thank you. Let me. Hello everyone, this is Akash here. Sorry for the delay. I was facing some network issue. And coming back to the presentation, as I mentioned, I'm Akash, and this project is done by me and my guide, Dr. in Rajati. So she is my guide, and we are part of Department of IT from Kumaraguru. Basically, the idea behind this specific topic of systematic benchmark and segmentation models under data scale condition is came when I was thinking about like the motivation of this project is basically behind what happens when the model doesn't have enough data to particularly perform on like sensitive subjects like medical based image segmentation. So we do have a lot of uh, deep learning based models which tend to perform very reliable when it comes to having the data in vast amount. But what happens when we have limited data, and but the condition that needs to be solved relies on that data. So while coming around that, I have found out that this particular disease called congenital heart disease (CHD) has one of serious conditions which affects 8 out of 10. Sorry, 8 out of 1,000 childbirths. But the amount of availability of this particular data set is very low. So, but this condition needs to be solved. But the restricting part is the data part. So, what I have done is taken this as a research problem to study like how we can build a model that can work under low data with a promising result. So when it comes to CHD, doctors usually go for CT scans and study the CT scans, and then they will like give the outcomes, and also diagnosis process is completely based on CT scans. But since these scans are done from childbirth, the visibility of such occurrence of disease is very hard. Like we cannot find it very hard, but a AI model could help. As I mentioned, the data is always a huge problem. So I have taken in account of that with available data called the image CHD, which had only 110 annotated data, which is very low for a deep learning model. Because traditionally a deep learning model need to have more number of data points to derive a decision, but this condition is very different. So and so that gave me the understand why can't we create a benchmark that evaluates the model that performs on low conditions. So that would be helpful for to create a framework that can work, that can build a deep learning model with such conditions. Okay, so as I mentioned, these are those are research gaps that I found, and coming with this particular problem with CHD, the main thing that we need is segmentation. So coming to segmentation, I was more looking to more many segmentation models such like unit, NN unit, and also medicine, which segments anything. So these are like a popular segmentation models. So I thought of, okay, testing these models with these limited data might help us to derive a conclusion how a model works on low data scale. So like to understand that, I have developed benchmark that evaluates 3 of this model using the same data set with the same pre-processing step and data split. Everything basically the same, but under 3 different models. That was the idea. So this gives a fair comparison for all these 3 models. And to go through this, I've found a few literature survey where basically it is related to unit is that proves that it can perform medical image segmentation. So I have taken that into consideration with that paper. And also later I have found out about the deep learning model, deep learning with the graph matching whole heart paper. Then from that I can able to find that segmentation using deep learning methods it's possible. And also more recently I've also seen how MedSum is performing with the pre-trained medical knowledge, because MedSum is basically a medical related data model. So taking these into consideration, I have tried to build the benchmark that could solve the particular problem that I have listed out earlier. And coming back to the data sets and experiment methodologies, we have used CHD data set I have mentioned, but in that 110 data, there are 16 different subtypes. With just 110, there are 16 different subtypes. So the task become much harder. So what I have done is, I have like before training all the CT scan model, I have went to traditional pre-processing models like sampling, normalization, crapping, and resizing. So these were all done. And then the data sets is divided into 67% of training and 15 for validation and 28 for testing. Since the lack of data, I have separated these into such cases. And also to study data scarcity, we trained the model with 100, 50, 20, and 10 different training cases. So to see how even with this 110, how the model is performing with 100% and 20 and 10% data. So we can like that will give us the validation and sets remain unchanged after like every experiment, and also make this benchmark testing more fair. Okay, and coming to the segmentation models, as I mentioned, I have used UNet, and its architecture is basically CNN architecture. And NN UNet is also it's based on the core is based on CNN. And also the medicine is foundation model, which is more trained on medical related data. So these models have different characteristics, and that really like help to ways to understand how each of this model encounters when the data is low. And for this evaluation, I have took 2 different metrics into consideration. One is dice similarity coefficient, then another is 95% hands-off distance. So I have taken these 2 into consideration. It's like because these 2 will help us to find like how their purpose is to evaluate how this model can able to identify the particular affected area, and how the models tend to perform it. Basically, it measures how closely the predicted segment and matches the actual segment. So that will be done by DSC. And also how HT95 will be performing, it's like it measures the distance between the predicted boundary with the actual data that is there. So this is how these both metrics have worked. And from based on the this result, based on this training and analysis part, I came to have this result as like the graph shows the dice score of all three models, and with 4 different training data sets. as the model training becomes more available, all three models perform better first at like 100%, and when it's dropped to 50, same goes to 10, they tend to lower their performance. Even in such conditions, the cases of medicine is always little bit better than compared to the comparative models. So overall, these results show like how model depends, like how best model depends on how much data label data is available. So, but even at such conditions, they tend to have a little advantage over other models. So that is in this case, Medsum is better. Maybe in different cases, other two models or another segmentation model could perform better. But this sets a benchmark, like we could evaluate all these things under the table is a representation of the same graph. We can see how each of this model performs on different metrics with the 10% and 20 and 50 and 100% ratio. And Medsum tends to take most of the advantages here. So seems in this particular review, the Medsum may have an uplift, but this creates a foundation that we could evaluate these models with such low data. So that is one of the major finding. Also, this helps to researchers understand how label data need to be choosing more like for a segmentation model. It also helps the hospital to plan annotation more efficiently, that using like expert annotation, which takes more time and cost. And also this the practical impact is like anyone cannot annotate the medical data, because those need to be done by an expert. So when the availability is low, we can use these conditions to see a better result, and also evaluate. We have as we have like evaluating multiple models, we do have extra set of models that tends to perform on these conditions. And the future works is basically we can also include in 3D datasets which are very limited to current datasets, and we can also like use semi-supervised learning, which includes like sort of labeling techniques, which helps the annotators. They can just evaluate whether the annotated part is wrong, right or wrong. So that we can use with this, even with this limited data, this can do this. We can expose this benchmark to multiple to larger database to see how each model performs, to eliminate the options, and we can choose the best out of the model that we out of the options that we are going to choose. Yeah, basically that is all. Thank you. Hello.
Now, what are the major contributions you have done into this project?
Yes, basically it's not like a established framework, but it's a idea of creating a benchmark that can evaluate the model in different conditions.
Okay, which type of model you have built?
I have used three different models: UNet, UNNet, and also Medicem. Because each of them have their own advantage. Medicem is basically more segmentation models trained with more medical data, and UNet has CNN architecture, and also UNN has the UN as a base, and also has its own characteristics. So that these three models I have used.
Okay, thank you. Thank you.
Thank you.
All right. We'll now move towards the closing remarks. I sincerely thank all the authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope the session was informative for everyone, and on behalf of the entire team, I thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within the next 2 working days. The publication will be live in 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I also thank our chair, Dr. Nilesh Sable, for chairing the session. A token of appreciation to the chair on behalf of Team ICT4SD 2026 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence.
Thank you, ma'am. Thank you so much.
Before we end the session, I kindly request everyone to please turn on their cameras for a quick snapshot.
Thank you.
Thank you so much. The meeting is now
Thank
adjourned.
you. Thank you.